Hello friends, welcome back to my YouTube channel. So in today's video we will solve a problem of truss. So how to analyze this by using the flexibility method or force method we will see. So in previous video we have seen the how to analysis of beam and frame by using the flexibility method. So today we will see how to analyze the truss by using the flexibility method. So this is our given problem. So analyze the pin jointed plane truss shown in figure by flexibility method and calculate the member forces. So this is the given truss problem. So usually first thing what we have to do is we have to find out the degree of static indeterminacy for this truss. So for that we have the formula. So I have already made the separate video for degree of static indeterminacy for plane trusses. So I will give link in the description box. So you can go through this video if you want. So for truss we have the formula ds is equal to m plus r minus 2 into j. Here m is nothing but number of members and r is nothing but reactions, j is nothing but number of joints. So by using this formula we have to find the degree of static indeterminacy. So now we will see. Our formula is ds is equal to m plus r minus 2j. So here m is nothing but members. M is nothing but members. How many members are there? So 1, 2, 3, 4, 5, 6. So member is 6 plus unknowns. How many unknown reactions are there? At in support there is 2 and at roller there is 1. Total number of unknowns are 3. So 6 plus 3 minus 2 into how many joints are there? 1, 2, 3, 4. Number of joints are 4. So now solve it. It will come out as 1. So 1 means number of redundant is 1. So now the structure is statically indeterminate. To make it statically determined, we have to remove the one redundant in this structure. Here ds value is 1. So you might have seen the problems of beams, and in case of beams and frames, there we usually take a support to select the redundant according to the ds value. It may be 1 or 2. So, and how many ds value we get in a particular problem, that many redundant we have to select in case of beam and frame as well as trusses. But here in case of truss what happens is we have to the ds value, it may be whatever we get, according to that we need to select the redundant. But the only thing change is here we need to select the redundant only the diagonal members. It may be AD or CB. So we need to select only diagonal members in case of trusses. We should not select the support, or we should not select this horizontal member AB and CD and vertical member AC and BD. We should not select it. Always remember this. In case of truss we need to select the redundant as the diagonal member. Any one of these AD or CD we need to select within these two only. We should not select the horizontal and as well as vertical members. So here I am taking the. So in case of beam and frames we have select a support to select the redundant. This is the different thing we need to remember when it comes to the trusses. So now our ds value is 1. I am selecting the member AD as the redundant and I will remove it. This is the remove structure. I have removed the AB member here. So here see here at point C point load is coming 20 kN of, and at point D 30 kN of point load is going outward. So this is point D. So now what we have to do is here at point A hinge is there, in support is there. At in support usually how many reactions takes place? 2 reactions. One is vertical, call it as VA, and one is horizontal, call it as HA and VA. At point B roller is there. So roller means how many reactions it has? It has only one reaction, that is vertical, call it as VB. So now we need to find out these reactions. So now, and this diagram is called as the P analysis. So I will write here. So it is called P analysis, where we need to find the reactions of this, and after find outing the reactions we need to find the, according to the method of joints, we need to find the forces in each member. So I will step by step I will show you. First we will find out the reactions of these. Summation of all the moment about A is equal to 0. Clockwise we need to take the positive. So here VB is going like this, now anti-clockwise. So VB into minus VB into, so at a distance of it is 4 meter. I will write it here. It has a distance of 4 meter. VB into 4, and this is also coming clockwise. Now it is rotating clockwise 30 kilonewton. So plus 30 into the perpendicular distance of this is 4 meter, 30 into 4, and the 20 kilonewton is axial to this. So we axial to this means the value becomes 0 is equal to 0. So now find the VB here. Here how to solve it, I'll show you. Alpha minus alpha x into 4. So VB is nothing but our x. We need to find that. Plus 30 into 4 is equal to 0. So now solve it. So our VB value will come out as 30. So 30 means it is positive 30. So VB is equal to 30. It means going upward. So whatever the direction we have assumed was right. The direction which we have taken upward, it is right. So now similarly for, we need to find the VA and HA. So summation of Fy is equal to 0. Upward we need to take the positive. Here VA is moving upward. So VA plus VB is also moving upward. VB value we got was 30. So put it here. Here one vertical of 20 kilonewton, it is coming downward. So minus 20 is equal to 0. So now solve it. VA is nothing but our x, which we want to find out. Plus 30 minus 20 is equal to, it will come out as, x will come out as minus 10. So VA, x is nothing but our VA. So VA come out as minus 10. So minus 10 means downward. So see here the direction what we have considered was initially it is upward. So it means the whatever the direction we have taken was incorrect. So we need to change the sign. So it is moving downward like this. We need to change it. It is moving downward. So it has the value of 10. Similarly, we need to find the HA. For that, summation of all the horizontal forces is equal to 0. So we need to take positive left to right here, and we need to take the negative, which is going right to left. So here the horizontal one is 30. It is moving positive. So 30 plus here HA is moving like this. It is also positive. Is there any horizontal one? No, only 2, HA and 30. So is equal to 0. So our HA will come out as minus 30. So minus 30 means it is moving like this,
right to left side.
arrow mark should be here. So see here, initially we have considered inward. So make it as outward. The force is going like this outward. It has the value of 30. So it is moving like this. So what we have assumed was incorrect. So now we got all the value. So VB we got was 30 here. So HA, VA and VB we got all the reactions. So now what we have to do is, now we need to find by using the method of joints, we need to find the forces in each member. It may be whether it may be compression or tension or compression. We need to find according to that, according to the method of joints we need to find and write it here all the value. So I will tell you. So the main rule of method of joints is we can select the joint where it should has only 2 unknowns. So when a joint has only 2 unknowns, then you at that joint you can easily apply the method of joint, and by using that you can find the forces easily. So see here at point A it has the only 2 unknowns and 2 knowns. You can apply the method of joints at this joint and you can easily find out the forces. And at support B it has 1 known and 3 unknown. So you cannot apply the method of joint to the joint B. So we cannot take it because it has the 3 unknowns. So our rule says the joint should have only 2 unknowns to apply the method of joints. So more than 2 unknowns we cannot apply the method of joints. See here our joint D has 1 known and
2 unknowns.
You can add this joint, you can apply the method of joints and you can solve it. And at joint C 1 known is there and 3 unknowns are there. So we cannot apply here also method of joints, we cannot take it. Because our method of joint rule says we can only apply the method of joints at the joints which has only 2 unknowns. So if a joint has more than 2 unknowns like 3, 4, we can add that joint, we cannot apply the method of joint. So this is our rule of method of joint. So now you can take the joint A or joint D. You can solve it by using these two. So now I am taking the joint A to find the forces. So now, so I'll consider this joint A. So consider joint A. So for this here we need to take only this portion. So remaining we should not see. So here I will redraw this diagram here. Joint A. So here 30 kilonewton is going outward now. As it is, we need to draw it. We'll draw here. So it is 30, and here one VA, it has the 10 kilonewton, it is also going downward. It has the 10. So from here to here, the AB, the unknown forces, you need to assume it as the outward only. So outward means AB, and here also one force is going, we need to assume it as outward only. Always we need to take the outward direction only for unknowns. It is the AC. So it AC and AB, and it has a 30 and it has a 10. So one simple thing I will tell you. So how to calculate this? If this member has the 30, so opposite of it also has the 30, but the direction will change. So if it has a minus 30 means obviously the answer of AB will be 30, positive 30. So it has the 10. So opposite of it is AC, it obviously it has the positive 10 only, positive 10. So it is the simple trick too. In exams you can calculate by using this trick easily. So to save the time. So also I will calculate it how it come 10 and 30 by using our standard formula. So see here, if we apply the summation of all the vertical forces is equal to 0. Upward we need to take the positive. Here upward vertical forces are, see here AC. Initially we don't know the value of AC, no? So put it here, AC is upward. So AC here on vertical is 10. So it is moving downwards, when you take the minus 10 is equal to 0. So our AC will come out as 10. So it is upward. See here, it is upward. Upward means, so tension. When you get the answer in positive, that means I will tell you the sign convention. Wait, later I will tell you. First I will find the AB also. Summation of all the horizontal forces is equal to 0. We need to take from left side to right side, which is moving, we need to take the positive, and there right side to left side which is moving, we need to take the negative here. And here horizontal one is AB is moving like this, so positive AB, and 30 is moving like this right to left. Now we need to take the minus, so minus 30 is equal to 0. So our AB will come out as 30. So it is also positive. Positive means it is in tension. So now I will tell you the sign convention of this. When we need to, when you get answer as positive, so it means the member is in tension. So when you get the answer as negative, it means the sign convention will be, I will tell you. See here, when the forces are moving towards each other, it means, so it means it is in tension. So when you get the positive value, so when you get the answer positive, the sign convention of that is positive, it means it is in tension. So when you get the answer in negative, so it means they are moving away from each other. So it means it is in negative. Negative means it is in compression. So this is the sign convention of trusses. So while solving problem, it is very important. If you get positive answer, the sign convention of that is towards each other, means it is in tension. So when you get the answer as negative, that means the sign convention of that will be away from each other. So away from each other means negative. So negative means it is in compression. So this is we have to remember this one. So now we have got the value of AC and AB. So AB also we got the positive answer, means it is in tension. So AB is also we got the positive. Positive means tension, moving towards each other. Tension means towards each other. So AC value we got was 10. 10 means positive, 10 means tension, moving towards each other. So AC value 10 means towards each other. So whatever the value, if you get the value in positive, you need to write it down in the positive only. If you get the negative answer, then you need to keep that value as it is. So if you get positive, keep that as positive, and if you get the negative value, keep that with the negative sign only. So our AB value also we got was 30. 30 positive 30 means, so it is also moving towards each other. So towards each other, the value we got was 30 for AB. It is 30. For AC, it is 10. Now we'll take the joint C. It has the 2 known and 2 unknowns. We can easily calculate it. So now consider the joint C. Now draw as it is. So you only see this portion. You have to see only this much of portion. So point C, joint C has the 20 kilonewton, and here one load is here moving downward, that is 10 kilonewton, and from here your own diagonal element will come, member will come. I will draw it here as it is. So I will draw it as it is. So 30 kilonewton it is coming downward, 30 kilonewton, and it has the CD. We don't know means we need to outward, take it outward only, away from the joint. Consider it as away from the joint. Here 10 kilonewton. So we got the value of C as 10 kilonewton, and we don't know value of the CD. Here one diagonal will come, make it as away from the joint, call it the diagonal of CB, the diagonal element of CB. So here the diagonal element, it has the theta. So it has the theta. So theta means here 2 component will come. So which has the angle, it has the cos term. So cos theta, CB cos theta, CB cos theta, and CB sin theta, which doesn't have the angle. It has the sin term, which has the angle, that has the cos term. So it is CB cos theta and CB sin theta. So now how to find this, I will tell. So now take summation of all the vertical force is equal to 0. Upward we need to take the positive. So one more thing is, so when you don't know the value of this, so the direction of this you should take the away from the joint only, the unknown which you want to find. So always take away from the joint, consider it as away from the joint. So summation of Fy is equal to 0. Upward we need to take the positive. Here the vertical 30 kilonewton is moving downward, it means minus 30, and also 10 kilonewton are moving downward, so minus 10. Here on CB sin theta is also moving downward, means minus CB sin theta. Is there any vertical forces are there? No. So it's equal to 0. So now we need to find the theta. For that we have the formula. So you know tan theta is equal to, we have the trigonometric formula for tan theta is, so opposite by adjacent. So see here, for it has the angle, no, it has the distance of, it has the 4 meter, and it also has the 4 meter, it also has the 4 meter. It means, so tan theta is equal to 4 divided by 4 is equal to 1. So theta is equal to tan inverse of 1. Tan inverse of 1 means, so see here it is 20 kilonewton, not 30. So make it as 20. So here also make it as 20. So now, so the answer will come out as minus 42.42. So our CB will come out as minus 42.42. So write it here as it is. So minus 42.42. Minus means compression. So minus means compression. Similarly, we need to find the horizontal. Summation of all the horizontal force is equal to 0. CD is horizontal force. So from left to right we need to take the positive. It is moving left to right, it means positive CD. So our CB cos theta also moving left to right, it is also positive. CB cos theta is 45. So write it as it is. Is there any horizontal? No. Only 2 is equal to 0. So now we got the value of CB. So put it here. You will get the value of CD. So directly I will solve here. So wait, I will write it here. CD plus, So CB value we got was minus 42.42. So write it as it is. So minus 42.42 cos 45 is equal to 0. So some student will, what they will do is they'll put only C here. They don't put the negative sign here. That's why they'll get they may get the wrong answer. So that's why it's very important to keep the answer. If you get answer in negative, write it as it is. So don't get confused here. So many will do the mistake here only. So write it as it is. So it's very important. And now solve it. So our CD is nothing but the value what we CD is nothing but our x. So x plus minus 42.4 close the bracket and cos 45 is equal to 0. So now solve it. Our CD value will come out as 29.99. 29.99 means nearly equal to 30. CD value is equal to 30.
So CD is equal to 30. 30 means it's positive. Positive means it is in tension.
Members are moving towards each other. So here compression means members are moving away from each other. So now we got the CB value and CD value. So write it here. Mark the symbols. CB is minus 42.42. CB is minus 42.42. Compression it is means away from each other. So away from each other. Mark it here. Away from each other. So write it as it the value we got was minus 42.42. So similarly our CD value we got was 30. 30 it is positive, it is in tension. So towards each other. So tension means towards each other. CD is positive. So towards each other moving. 30 we got. So write it as it is. So now we need to find we got the CD members and this member, this. Now we need to find this member value. So for that, here calculate by taking the joint D, because it has only one unknown, and you can also calculate by using the B also, because here also you have the only one unknown. You can take whatever you want. So here 2 is known, 1 is unknown. So here you know the value of 3, only this one is unknown. So I will go with the D. So because I will take joint D, so it is easy to calculate. So it take only less time. So I will draw it as it is. So we need to see only this portion. This much of we need to see. So I will redraw the same diagram here. So I will draw the same diagram here. Here this is point D. So here also 30. Obviously opposite of this will be 30 kilonewton. Only sign will change. So here we don't know the value of dB. So it means sign we need to make the away from the joint. So is there any member? Are you seeing opposite to this? There is no member along to this axis. So it means our dB value becomes 0, because it has the no member opposite to this. So dB value becomes 0. We need to calculate in a very simple way. So dB value will get 0. Keep it as 0. Now we have calculated all the member forces of P analysis. So now what we have to do is, here our P analysis, the calculation of all the forces in P analysis completed here. Now we need to go for the analysis of K analysis. K analysis means we need to apply the unit load at the joint, at the member where we have considered as the redundant. There we need to apply the unit load of 1 kilonewton, and we have to remove all the external loads, that is 20 kilonewton and 30 kilonewton. We have to remove that, and we only apply the unit load of 1 kilonewton. So I will draw the diagram here and I will explain how to analyze that. See here, I have removed all the external loads, that is nothing but 20 kilonewton and 30 kilonewton. We need to apply the only unit load of 1 kilonewton. So whenever you apply the unit load, the direction should be away from the joint. So our AD is we have taken it as the redundant. So we need to apply here unit load of 1 kilonewton. Unit load of 1 kilonewton. The direction should be away from the joint. Away from the joint means like this. We need to take the away from the joints. So whenever you apply the unit load, the direction should be away from the joint. And how many members you remove, that many members you need to apply the unit load of 1 kilonewton. So a unit load should be applied according to the each member that is removed. So wherever you remove, at that point you need to apply the unit load of 1 kilonewton. And here one more thing is, here our reaction, so here our hinge is there, support, and here roller is there at hinge. So we usually have the two reactions. One is vertical VA and horizontal HA, and at point B is the roller support. It means it has the only one reaction, that is vertical. So here we don't need to find these reactions. So we only need to find the forces in each member. We don't need to find the reactions. That's why I'm not finding the reactions here. So in case of the P analysis, we need to find the reactions here. So that's why I have calculated the reactions here. Here we don't need to calculate the reactions. To save the time, I am not finding the reactions of these because it is not necessary for this. So this is called our K analysis. So this diagram is called as K analysis. So now we need to, by using the method of joint, we need to find the forces in each member. Again, the method of joint says we need to apply at that points which has the only two unknowns. See here our point as 1, 2, 3. Only one known and 4 unknowns is there. We cannot apply the method of joints at the joint A. And see at point B, 4 unknowns are there. We cannot apply. So here at joint D, 1 is known and 2 is unknown. You can easily apply the method of joints here at point D. At point C also 3 unknowns are there. You cannot apply the method of joints to joint C. So now we will see. I will start from the joint D because it has only 2 unknowns. And one more thing here is, so if you get here, we got the DS value 1. So for that we need to do the K1 analysis. So when you get the DS value 2, then we need to do the K1 analysis as well as K2 analysis. That will be changed according to your DS value. So now I will start from the joint D. Consider joint D. So we need to only see only this portion. So I will redraw the diagram, same diagram here. So this is the CD member and this is the DB. Here one unit load of 1 kilonewton is there and it has the angle theta. So for again it has the two terms which has the angle, that has the cos term. So 1, so that 1 cos theta and this is 1 sin theta. So now we need to solve it. So always we need to take the direction outward only. We don't have this value, no. For unknown values we need to take the away from the joint only. Away from the joint we need to consider. So now we will apply summation of all the vertical forces is equal to 0. Upward we need to take the positive. So here vertical force is 1 sin theta and dB is also vertical. So it is downward, now moving downward means we need to take the minus dB, and our 1 sin theta is also moving downward. So minus 1 sin theta value we got was 45. So sin 45, is there any vertical forces? No, only 2. So is equal to 0. So now by using calci we will solve it. Our dB is nothing but the value which we want to find. So dB is nothing but our x. So minus x minus sin 45 is equal to 0. So it will come out as, our x value will come out as minus 0.707. So x is nothing but our dB. So dB value will come out as minus 0.707. So I will write it here only. dB is equal to minus 0.707. So minus means compression. Similarly, summation of all the horizontal forces is equal to 0. So left to right we need to take the positive. So and right to left we need to take the negative. So our CD is moving right to left now, it means we need to take the negative. So minus CD, and our 1 cos theta is also moving right to left, it means negative, minus 1 cos 45. Is there any horizontal force? No, only these two, is equal to 0. Solve it by using calci. Minus x, our CD is nothing but our x. So minus x minus cos 45 is equal to 0. So the value will the value come out as minus 0.707. So our CD value is also minus 0.707. It is also compression. Compression means away from each other. So we need to mark it here. Our dB, so dB value we got was minus 0.707. Compression means away from each other. The forces are moving away from each other. So the value we need to write as it is, as I told you, minus 0.707. And similarly for CD value we got was minus 0.707. Again it is compression away from each other. So forces are moving away from each other. It also has the value minus 0.707 for CD. So now, we'll take the joint C. It has one known and two unknowns. We can easily calculate it. So consider the joint C. So now we only take this much of. I will redraw this here, and here at C, our CD is coming inward now towards the joint. It is coming. So it means like this, at joint towards the joint it is coming, and here one diagonal is there, and here also CA, we don't know the value, we need to take the away from the joint. So it is coming towards the joint, and one diagonal is there, the diagonal of CB is there. So diagonal of CB, so it has the theta. So again it has the two component, one is CB cos theta, another is CB sin theta. So which has the angle, that has the cos term, which doesn't has the angle, that has the sin term. So now, and for CD we already calculated the value. CD value we already calculated, that is minus 0.707. So write it here, CD 0.707. we don't need to put the negative sign here because the symbol itself says it is negative. So 0.707. now we'll calculate summation of all the horizontal forces is equal to 0. Here horizontal is here 0.707. it is moving like this now, right to left means negative. So minus 0.707, and the horizontal of CB cos theta is there, so it is moving left to right. We need to take the positive, plus CB cos theta. Is there any horizontal forces? No. So is equal to 0. So now solve it. CB cos 45 minus 0.707 is equal to 0. CB is nothing but x. So x cos 45 minus 0.707 is equal to 0. So it will come out as 0.99. So 0.99 means 1. So our CB value we got was 1. So CB value is equal to 1. So positive means it is in tension towards each other. Similarly, summation of all the vertical forces is equal to 0. Upward we need to take the positive. Here vertical force CA is upward, it is moving downward, so minus CA, and CB sin theta is also moving down, minus CB sin 45 is equal to 0. So CB value we got was 1, so put it here, minus CA is nothing but our x, minus CB is 1 sin 45 is equal to 0. So the value will come out as, CA value will come out as minus 0.707. So minus 0.707. So minus means it is in tension. Sorry, it is in compression. Minus means compression. So now we got the CB and CA value. Mark it here. CB value is tension 1. So it is in tension. CB value is tension means moving towards each other. Tension means towards each other. So value we got was 1, positive 1, and our CA value we got was minus 0.707. Its compression means away from each other. So CA's forces are moving away from each other. So minus 0.707. So now here at joint A, 2 knowns are there and still 3 unknowns are there, we can't take it. So here when it comes to joint B, we have 2 unknowns here, we can take it. So now I consider the joint B. So I will draw the diagram here. See here, one force is coming, minus 0.707. So it has the value of minus 0.707. So minus means it is coming towards the joint. So towards the joint B. So 0.707. The symbol itself says it is negative. So don't need to write the negative symbol here. And here also one diagonal, 1 kilonewton of diagonal is there. That is BC. So here it is going upward. So it has the value of 1. Similarly for BA, there is no forces, so take it as outward. So this is the BA. So here it has the theta. It means again 2 components will come which has the theta, that has the cos term. So 1 cos theta and here also 1 sin theta. So now solve it. Summation of all the horizontal forces is equal to 0. So here horizontal is 1 cos theta. It is moving from like this, no? Right to left means we need to take the negative. So minus 1 cos theta is 45 and BA is also moving left to right, it means negative. So what is this? This is 45 minus BA is equal to 0. Is there any horizontal force? No, only these two. So now solve it. BA minus cos 45 minus BA is nothing but our x is equal to 0. So our x BA will come out as minus 0.707. So minus means compression. So BA is minus 0.707. Compression means away from each other. See here for joint B. Here for joint B we need to find the only this member, that is AB. So now we have got the BA value. So BA value is minus 0.707. So we don't need to find our BD value because we already calculated the forces of this member, no? So that's why here we don't need to go for the summation of Fy vertical forces because we already known the value of this member, the vertical one. So that's why I am only applying here, calculating here summation of Fx is equal to 0 to know the forces in BA member. So now we have got that value. BA value is minus 0.707. So I am not going for the calculation of the vertical member. So because we don't need it, we already known the value of this member. So our BA value we got was minus 0.707. So minus means it is going away from each other. So away from each other means like this. So minus 0.707. We have calculated all the forces, member forces of K analysis as well as P analysis. So our next step is to find the, here we need to find this, fill this table, we need to find all the values here. So our table, it has the first column member and P analysis and value of K analysis and length and PKL, K square L and force is equal to P plus K into R. So now I will show you how to do this. So now we need to put here P analysis value of AB member, AC member, BC and CB corresponding values we need to put P analysis and K analysis and corresponding length also we need to put here. So for AB we have the value, for AB we have 30 and AC is 10. AB value is 10, value is 30, sorry, AB value is 30 and AC is 10 and BC is minus 42.42 and CD is 30. BC we got was minus 42.42 and CD we got was 30 and for BD we got the 0 and for AD we have considered it as the redundant. No, we don't have this value. See here AD we have taken as a redundant, so we don't have the P analysis value for AD, so keep it as 0. Similarly for K analysis, AB value we got was, I will write all the value here. For AB is minus 0.707 and AC also minus 0.707. So write it here. For AB minus 0.707, for AC also minus 0.707, for BC is 1, for CD also minus 0.707, for BD also minus 0.707, AD value is 1. AD value is 1. Similarly, our length of AB is 4 meter, so all the length is 4 meter only. Length of AB is 4 meter, AC is 4 meter, and for BC, AB is 4 meter and AC is also 4 meter. To find the CB, we need to find, what we have to do is, we need to do that there is one formula that you all know, that is nothing but our, wait, I will show you here. I will show you. BC square is equal to AB square plus AC square. So under root of AB is 4 square and BC is 4 square. So if you do this, our value will come out as under root of 4 square plus 4 square. So our value will come out as 5.65. BC value is 5.65. CD value also 4 and BD is 4 and AD is 5.65. So now what we have to do is we need to multiply these 3 and put it here. Similarly, for corresponding member, we need to multiply all the value P, K, L and put it here. Do this and put it here. So I will show only 2. If I keep calculating all the member, it will take, the video will get very lengthy. So that's why I will tell only 1. So 30 into K value is minus 0.707. So bracket minus 0.707, close the bracket, into L is length, L is 4 meters, so 4. So it will come out as minus 84.84. Minus 84.84. So put it here, minus 84.84 and K square minus 0.707. If you do, it will come out as K square minus 0.707, close the bracket. Now do this. The K square value come out as 0.49. 0.49 is nothing but 0.5. So K square is 0.5. K square into L, so 0.5 into 4. So 0.5 into 4, it will come out as 2. K square L value is 2. So for this, F is equal to P plus K into R. So for R, we have the formula. So I will tell this later. So I will find all the values similarly. So orally I will tell you. So 10 into minus 0.707 into 4, if you do, it will come out as minus 28.28. For K square, again it will come 0.5 and K square L is 2. If you do this, PKL value will come out as minus 239.67 and 1 square will be 1 and K square into L is 5.65. And for this, PKL value is minus 84.84 and our K square value 0.5. Again K square L is 2. For this also, the value is 0, 0 into anything becomes 0. So here the value is again 0.5. Here also 2. Again here 0 into anything becomes 0. So for this value is 1 and here 5.65. So now we have calculated the till here. So we need to do the summation of this PKL, summation of PKL. So if we do, it will come out as minus 437.63. If we add these all, so answer will come out as minus 437.63. So if you do summation of K square L, so if we add these all the values, this value will come out as 19.3. It will come out as 19.3. So here we know the value of P and value of K, but we don't know the value of R. No, for that we have one formula. So R is equal to minus summation of PKL divided by summation of K square into L. So minus of summation of PKL value is minus 437.63 divided by summation of PKL is 19.3. So if you do this, the value will come out as minus 400. Here also minus is there outside. So minus 437.63 divided by 19.3. If we do, so our value will come out as 22.67. So our R value will be 22.67. So now what we have to do is here, so put all the value. So P value we as 30. P value is 30. So 30 plus K value is minus 0.707. So bracket minus 0.707, close the bracket, into, so R value is 22.67. So it will come out as 13.97. So 13.97. Similarly, you need to do all the value. So I will orally do it. So for AC, the value will come out as minus 6.02. So minus 6.02. For BC, for member BC, the value will come out as minus 19.75. For CD, the value will be 13.97. For BD, the value will be minus 16.07. For AD, the value will be 22.67. This is the final value of our P. So this is how we need to find all the values in this table. So here our problem ends. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.